Pleasant day, everyone. I am Jeline C. Pipito, best in Math 1A. In this video, we will tackle about the 17th century, the important discoveries in the field of astronomy and physics and in mathematical formulas, which was accepted in Greece until refined by Eratosthenes in around 250 BC. Some scholars accepted that he discovered that the ecliptic was at an angle but doubt that he measured the angle. Enopides also credited with suggesting a calendar involving a 59-year cycle with 730 months. Others came proposed were 8-year cycles with the extra months in 3 of the 8 years, and that there is evidence that this scheme was adopted. Pythagoras. He recognized that the earth was a sphere, probably more because he believed that a sphere was the most perfect shape than for genuine scientific reasons. He also recognized that the orbit of the moon was inclined to the equator of the earth, and he was the one of the first to realize that Venus as an evening star was the same planet as Venus as a morning star. There is a pleasing appeal to observational evidence in these discoveries, but Pythagoras had a philosophy based on mathematical perfection, which tended to work against a proper scientific approach. On the other side, there is an important idea in the Pythagorean philosophy, which had a lasting impact, namely the idea that all complex phenomena must reduce to simple ones. Astronomy is the most ancient of the sciences, having existed since the dawn of recorded civilization. The 17th century witnessed several momentous developments that leads to major advances in astronomy, where Johannes Kepler discovered the principles of planetary motion and also worked on and designed better cameras and telescopes to use for observation. Kepler's law of planetary motions. The planets orbit the sun in ellipses with the sun at one's focus. Equation of time. The line joining the sun and the planet sweeps through equal areas in equal time. The square of the period of the orbit of a planet is proportional to the cube of its semi-major axis, half the longest dimension of the ellipsis. A mission aimed at detecting planets around other stars has been named after Kepler. Hans Lippershey was born in Middelburg, Zeeland in September 1608, the first known patent for workable telescope. He invented the first refracting telescope, named spyglass. Harriot, a British astronomer, and was using X6 power spyglass for observing and mapping the surface of the moon. Galileo Galilei, the Italian mathematician. Galileo Galilei develops an astronomical telescope powerful enough to identify moons orbiting Jupiter, sunspots on the Sun, and the different phases of Venus, all of which are instrumental in convincing the scientific community of the day that the heliocentric Copernican model of the solar system is superior to the geocentric Ptolemaic model. Astronomy comprises the study of all extraterrestrial objects. Until the invention of the telescope and the discovery of the laws of motions and gravity in the 17th century, astronomy was primarily concerned with noting and predicting the positions of the sun, moon, and planets, initially for calendrical and astrological purpose, and later for navigational applications and scientific interest. Physics. In the 16th and 17th century, European scientists began increasingly applying quantitative measurements to the measurement of physical phenomena on the Earth. The Copernican revolution, or the paradigm shift from the Ptolemaic model of the heavens to the heliocentric model with the Sun at the center of the solar system, began with the publications of Copernicus' De Revolutionibus Orbium Celestium and ended with Newton's work over a century later. Galileo showed a remarkably modern appreciation for the proper relationship between mathematics, theoretical physics, and experimental physics. His contribution to observational astronomy include the telescope, confirmation of the phases of Venus, the discovery of the four largest satellites of Jupiter, and the observation and analysis of sunspots. Dr. William Gilbert invented the new Latin word electricus from electron, the Greek word for amber. Gilbert undertook a number of careful electrical experiments, in the course of which he discovered that many substances were capable of manifesting electrical properties. He also discovered that a heated body lost its electricity and that moisture prevented the electrification of all bodies, due to the now well known fact that moisture impaired the insulation of such bodies. He also noticed that electrified substances attract all other substances indiscriminately, whereas a magnet only attracts iron. By the end of the 17th century, researchers had developed practical means of generating electricity by friction with an electrostatic generator. But the development of electrostatic machines did not begin in earnest until the 18th century, when they became fundamental instruments in the studies about the new science of electricity. The first usage of the word electricity is described to Thomas Browne in 1646 work. In 1729, Stephen Gray demonstrated that electricity could be transmitted through metal filaments. René Descartes, a French philosopher, outlines a model of a static, infinite universe made up of tiny corpuscles of matter, a viewpoint not dissimilar to ancient Greek atomism. In 1632, Galileo first described the principle of relativity, the idea that the fundamental laws of physics are the same in all inertial frames, and that purely by observing the outcome of mechanical experiments, one cannot distinguish a state of rest from a state of constant velocity. Galileo Galilei improved the telescope, with which he made several important astronomical discoveries, including the four largest moons of Jupiter, the phases of Venus, and the rings of Saturn, and made detailed observations of sunspots. He developed the laws for falling bodies based on pioneering quantitative experiments, which he analyzed mathematically. Galileo Galilei demonstrates that unequal weights would fall with the same finite speed in a vacuum, and that their time of descent is independent of their mass. Thus, freely falling bodies, heavy or light, have the same constant acceleration due to the force of gravity. Sir Isaac Newton. Isaac argues that the light is composed of particles, which are refracted by accelerations toward a denser medium, and posits the existence of ether to transmit forces between the particles. Emanuel Swedenborg proposes a hierarchical universe, still generally based on a Newtonian static universe, but with matter clustered on ever larger scales of hierarchy endlessly being recycled. This idea of a hierarchical universe and the nebular hypothesis were developed further. Johann Heinrich Lambert supports Wright and Kant's hierarchical universe and nebular hypothesis, and also hypothesizes that the stars near the Sun are part of a group which travel together through the Milky Way, and that there are many such groupings or star systems throughout the galaxy. John Michell. The amateur British astronomer John Michell proposes the theoretical idea of an object massive enough that its gravity would prevent even lights from escaping, which has since become known as a black hole. He realizes that such an object would not be directly visible but could be identified by the motions of a companion or star if it was part of the binary system. A similar idea was independently proposed by the Frenchman Pierre Simon Laplace in 1795. Mathematical formulas. In the wake of Renaissance, the 17th century saw an unprecedented explosion of mathematical and scientific ideas across Europe, a period sometimes called the Age of Reason, hard on the heels of the Copernican revolution of Nicolaus Copernicus in the 16th century. Scientists like Galileo Galilei, Tycho Brahe, and Johannes Kepler were making equally revolutionary discoveries in the exploration of the solar system, leading to Kepler's formulation of mathematical laws of planetary motion. John Napier, the invention of logarithm in the early 17th century, contributed to the advance of science, astronomy, and mathematics by making some difficult calculations relatively easy. Mersenne. In modern times, the largest known prime numbers has been a Mersenne prime, but in actual fact, Mersenne's real connection with the numbers was only to compile a none too accurate list of the smaller ones. René Descartes, his development of analytic geometry and Cartesian coordinates in the mid-17th century soon allowed the orbits of the planets to be plotted on a graph, as well as laying the foundations for the later development of calculus, and much later multi-dimensional geometry. Paris de Fermat formulated several theorems which greatly extended our knowledge of number theory, as well as contributing some early work on infinitesimal calculus. Blaise Pascal. He is best known, however, for Pascal triangle, a convenient tabular representation of binomial coefficients, where each number is the sum of the two numbers directly above it. A binomial is a simple type of algebraic expression, which has just two terms operated on only by addition, subtraction, multiplication, and positive whole number exponents, such as x plus y squared. The two coefficients produced when a binomial is expanded form a symmetrical triangle. Euclid's Elements. Euclid's work built the foundation for modern mathematics by introducing a set of axioms and proceeding to demonstrate by mathematical rigor a collection of theorems that naturally followed. The 17th century saw Napier, Briggs, and others greatly extend the power of mathematics as a calculatory science with his discovery of logarithms. Cavalieri made progress towards the calculus with his infinitesimal methods, and Descartes added the power of algebraic methods to geometry. Progress towards the calculus continued with Fermat, who, together with Pascal, began the mathematical study of probability. However, calculus was to be the topic of the most significance to evolve in the 17th century. Newton, building on the work of much earlier mathematics, such as his teacher Barrow, he developed the calculus into a tool to push forward the study of nature. His work contained a wealth of discoveries, showing the interaction between mathematics, physics, and astronomy. Thank you, and that would be all.